Section 7.3, Sum and Difference Identities. In this section and the next, we are going to be adding more formulas to our identity toolbox. In section 7.3, we are going to be reviewing the sum and difference identities. And in section 7.4, we will be studying the double angle formulas as well as the half angle identities. So in this section, like I said, we will be taking a look at the sum and difference identities. Before I get into what exactly those say, I want to remind you that distribution does not apply to functions. So to see what I mean by this statement, let's take a look at example 1. It says if a is equal to pi over 2 and b is equal to 0, find each of the following. So here, remember, a and b are angles. We're going to compute the cosine of the quantity a minus b, and then we're going to compute the cosine of a minus the cosine of b. All right, so let's start with the first expression. The cosine of a minus b, okay, I'm just going to plug in for a and b. That's going to be the cosine of pi over 2 minus 0. So then I'm going to simplify what's in parentheses. I'm just following the order of operations. This tells us that we're taking the cosine of pi over 2. Okay, so remember what the cosine of pi over 2 is. If I just go to my unit circle, find pi over 2, find the point that corresponds to pi over 2, the x-coordinate is 0. Okay, so the cosine of pi over 2 is 0. Okay, so that means this expression, the cosine of a minus b, is equal to 0. Okay, so now I'm going to go and take a look at this other expression, okay, which is different. This time it's the cosine of a minus the cosine of b. Again, I'm just going to plug in the a and b values. This is going to be the cosine of pi over 2 minus the cosine of 0. Okay, these are both angles in radian measure. Okay, so the cosine of pi over 2, we just saw that that is 0. We're subtracting the cosine of 0. Okay, if we go back to the unit circle, here's 0 radians. Here's the point we need to be looking at to compute the cosine. The corresponding point on the unit circle is 1, 0. Look at the x-coordinate. That means the cosine of 0 is 1. All right, so we're subtracting the cosine of 0. The cosine of 0 is 1, so the expression simplifies to be negative 1. Okay, these two guys are not the same value. Okay, which means that the expressions are not equal. Okay, we plugged in a and b to both of them and we got different results. So the moral of the story here is that cosine of a minus b is not the same thing as the cosine of a minus the cosine of b. Meaning you cannot distribute. It is incorrect to take this cosine of a minus b and make it cosine of a minus cosine of b. Okay, so you cannot distribute through any trigonometric function. Okay, that's what you should take away from this. Okay, you can't do it. I know we just did one example here, but again, this applies to every single trigonometric function. Okay, if we were dealing with sine or tangent or cotangent, or if we had a plus sign in the middle, you can't distribute. Okay, so what does happen to cosine of a minus b? Okay, can you expand it in a certain way? Okay, and the answer is yes. You can do quote-unquote distribution, but it's not what you think. Okay, if you read the statement that's below this example, it says the correct way to quote distribute a trigonometric function is given by the sum and difference identities. Okay, so if you scroll down to the middle of page 1, in the box you will see the sum and difference identities. Okay, and like I said, this is the way you kind of distribute through cosine, sine, and tangent. Okay, so here they are. I'm going to read through them, and then the rest of this section we will be getting practice with these particular identities. Okay, so identity number 1, the cosine of A plus B. Okay, remember what that means. You have two angles A and B. You are adding the angles first, and then you're taking the cosine of that new angle. Okay, again, it is incorrect to say that this is the cosine of A plus the cosine of B. Okay, what is correct is what's on the right side of the equal sign. The cosine of the quantity A plus B is equal to the cosine of A times the cosine of B minus the sine of A times the sine of B. Okay, so that's the first formula. This is the sum identity for cosine. Then there's a separate formula that you will see in identity number 2 here for the cosine of A minus B. That is a different formula. The cosine of A minus B is equal to the cosine of A times the cosine of B plus the sine of A times the sine of B. Okay, moving on to the identities in 3 and 4, we're going to take a look at the sine formulas. The sine of A plus B in formula number 3 is equal to the sine of A times the cosine of B plus the cosine of A times the sine of B. And in identity 4, the sine of A minus B is equal to the sine of A times the cosine of B minus the cosine of A times the sine of B. And then in equations 5 and 6, we will look at the tangent identities. In equation 5, the tangent of A plus B is equal to the tangent of A plus the tangent of B, all divided by 1 minus the tangent of A times the tangent of B. And then lastly, equation 6, the tangent of A minus B is equal to the tangent of A minus the tangent of B, all divided by 1 plus the tangent of A times the tangent of B. Okay, so these identities will be super helpful. Okay, so keep them in the back of your mind. Okay, so let's do another example. Okay, so if we move down here, one of the things that you can do, we're going to start off with a really simple example that some of your homework problems will look like. Okay, we're going to use these sum and difference identities to write a function as an expression involving just a function of theta. Okay, so that title is a little confusing. I mean, if you read it again, writing functions as expressions involving functions of theta, what does that mean? Okay, so let's just read through the example and then I'll explain what these directions mean. Okay, example 2, write the function as an expression involving functions of theta alone. And our expression just means you're working with something that doesn't have an equal sign. Okay, so there's nothing to solve for. Okay, our expression is the sine of the quantity 120 degrees plus theta. Okay, so what we want to do, what these directions mean if you translate them, we want to rewrite this as an equivalent expression, but the only argument can be theta. Okay, we don't want to see the 120 degrees anymore. Okay, if you're taking the sine or even the cosine or the tangent or whatever trig function is involved, the argument has to be just theta. Can't be more complicated than that. Okay, all right, so when you look at this expression that we've been given, it is the sine of something plus something. Okay, so A here would be 120 degrees, and then B would be the angle theta. Okay, so what you would do here is apply the sum identity for sine. Okay, so I'm going to write this out to the side. The sine of A plus B, that's what we're going to use here. So you can scroll back up. We're going to be using formula number 3, okay, because we're involved with a sine here and we're adding. Okay, so this is a sum formula for sine. Okay, so I'm going to go ahead and write down what that is equal to. This is going to be the sine of A times the cosine of B plus the cosine of A times the sine of b. Okay, I'm going to apply this, but like I said, if you line this up, this left-hand side, if you line it up with the sine of 120 degrees plus theta, we're going to make the substitutions that we just talked about. Okay, we're going to substitute a equals 120 degrees and b is equal to theta. Okay, so this is going to be the sine of 120 degrees times the cosine of theta plus the cosine of 120 degrees times the sine of theta. All right, so in a sense, we've used this identity to distribute or expand this expression. Okay, now look at what we're left with. Okay, the sine of 120, we can actually figure out what that is, as well as the cosine of 120 degrees. Okay, so let's go and figure that out. Let's start with the sine. So I'm going to go to my unit circle. I'm going to find 120 degrees. That's right here. So I'm going to be focused on this ordered pair. Okay, so from the looks of this, okay, the cosine of 120 degrees is going to be the x-coordinate. It's going to be -1/2, and the sine of 120 degrees is going to be the y-coordinate, which is the positive square root of 3 over 2. Okay, so now I'm going to go plug those values in. Okay, so the sine of 120 degrees is the square root of 3 over 2. We're going to multiply that by the cosine of theta, and then we're going to add the cosine of 120 degrees, which we said is -1/2, and we've got to multiply that by the sine of theta. Okay, so we plugged in, we were able to compute those two trig values. Okay, as far as the cosine of theta and the sine of theta, we don't know what theta is, so we can't do anything else with those pieces. Okay, we can simplify a little bit. Okay, we can make this the square root of 3 over 2 times the cosine of theta minus 1/2 times the sine of theta. Another thing, this is perfectly fine to stop here. Another thing you can do is you can actually factor out a 1/2. Okay, if you factor out a 1/2, that's going to leave you with the square root of 3 times the cosine of theta minus the sine of theta. Okay, so either one of these guys, these last two statements, will suffice. Okay, we've done what we've set out to do. Okay, we started with this expression, okay, this expression in yellow, and the goal was to rewrite it so that the arguments, the things that we're taking the trig functions of, we're taking the things that we're taking the sine and the cosine of, the arguments are all theta. Okay, we didn't want to be taking like the sine or the cosine of 120 degrees. And you can see in our answers that we've done that. Okay, all the arguments are just theta. Okay, so in order to do this problem, you had to recognize that the sum formula for sine had to be applied.